volume, particularly volume of a prism. That's what they expect you to be able to do. Okay, you'll notice at the bottom I've pointed out that actually they do give you this information on the formula sheet. If they want you to do the volume of a more complex shape, then they will give you the formula within the question itself. So what is volume? Think about volume in terms of filling space. Okay, volume is measured literally in cubes. I don't know whether you want to sort of imagine in your head sugar cubes or OXO cubes all stacked together, how many would fit into the space that you've got. That's how we're measuring volume. So obviously that's not very practical, so that's why we have some formulas that we can use. Now, a prism is a shape where if you cut through it at any point, you're going to get the same shape and the same size everywhere you cut through. So imagine something like a Swiss roll. If you chop through, it's going to be the same shape wherever you cut through, as long as you cut obviously in the same, straight down in the same way. So common prisms are things like a cuboid is a prism, a cylinder is a prism, and then the clue's in the name here, but you have a triangular prism. Those are the three main ones you're probably going to come across, okay? But they don't have to be regular shapes like that. They can be more complex, as we'll see. So what it tells you on the formula sheet is that you need to find the area of the cross section. So think about that as being the end, the face on the end of the shape. You find the area of that, and then once you've got that area, you simply multiply it by the length or the height, depending on how you're looking at the object itself. So let's do some examples. So we'll start with the most basic, which is a cuboid here. So this cuboid is 9 this way, it's 2 going back, and it's 3 tall. So if we think about the cross section, which I'm just going to kind of shade in here, okay, so that's a rectangle on the end here, and so we know that we find the area of that by multiplying the width and the length, or the height in this case, together. So the area of the cross section in this case is 3 times 2, which is 6, and then to get the volume we take the area and we multiply it by the length here, which is 9, so we get 54 centimeters cubed, remember. Okay, so one more very quickly. So we've got 5 this way, 3 and 3, so our cross section here is actually a square, even if it doesn't look like it. Okay, so the area of the cross section is 3 times 3, which is 9, and then the volume is 9 times the 5, which is 45 centimeters cubed. So now let's look at a slightly more complex prism. So here we can see we've got a more complex shape. We've got an L-shaped thing. Okay, so we're going to need to find the area of this cross section first of all, and because it's an L shape, we're going to split it into 2 rectangles. Okay, so this smaller rectangle here is 5 across here and 3 this way. That's what it's telling us here. Okay, so 5 times 3 is going to give me 15. So now I need to work out the bigger one here. So we've got 8, so one of our sides is 8, and we've got to figure out how wide it is here. So all the way across is 9, this bit is 5, so this bit must be 4. So 8 4s are 32. Add those together and we get 47, and that is the area of our cross section. So now all we've got to do is look at the diagram and find out how far it goes back, which in this case is 10 centimeters. So our volume is the 47 times 10, which equals 470 centimeters cubed. Okay, let's look at a couple more examples. I hope you can see this one. It's a little bit of paint, but this is a, let me try and sort of sketch it over a bit more. This is your typical triangular prism. I'm not going to draw all the lines in, but hopefully that's making it a little bit more obvious. And it's telling me this is 12 along here, 5 along here, and then the perpendicular height here is 4. So first of all, we need to find the area of this cross section, which is a triangle. So that means it's a half times the base times the height. So it's a half times 5 times 4. Let's do a half of 4, which is 2, times 5 is 10. So our area is 10. So then our volume is going to be 10 times the 12. Going back there, so it's 120 centimeters cubed there. Okay, so here we've got an unusual shape. We've got a pentagon turned into a prism, but they've made life super easy for us because they've actually already told us what the area of this cross section is. So don't panic. So all we've got to do is take that area, 21, and multiply it by how far it goes back. So 6 times 21, 6 20s is 120, plus 6 more, 126 centimeters cubed. Okay, so the one shape we haven't had yet is the cylinder. So let's just do a couple of cylinder examples. So again, hopefully you can pick this out. So here's our cylinder here, and it's telling us that it's 5 centimeters high, and then it's given us the radius inside here as being 2. So this time our cross section here is a circle, and the area of a circle is pi r squared. So in this case it's pi times 2 squared, or 4. So let's work that out. So shift to get pi, multiplied by 4 equals 12.57 to 2 decimal places. I'm going to leave it on the calculator because now we need to take that number, the 12.57, and multiply it by 5, the height of the cylinder, to get the volume. So we'll times by 5, and that gives us 62.83 centimeters cubed. Okay, so one more here. So we've got another cylinder here. Just roughly draw that in again so you can see it a bit better. Okay, and then it tells us this distance here is 12 and this is 6. So the area of our circle is A equals pi r squared. So be careful because that is the diameter, isn't it? So it's pi 6 squared, not pi times 12 squared. So on the calculator, shift pi times 6 squared equals, that gives us 113.1 to 1 decimal place. Okay, and then the volume is what we get when we take that and multiply it by the 6, the height of the cylinder. So times by 6 equals 678.6 centimeters cubed. So there we go, volume of prisms.